stopping in. I just want to do a short video today looking at the uses of modules in electronics. It seems like that's all everything is today, is modules. You take and you look and you have your audio modules, your power supply modules, etc. If you take and do a search in electronic modules in eBay, you'll come up with 172,000 different listings for electronic modules, ranging anywhere from 75 cents for a astable multi-vibrator kit to $16,000 for an Agilent microwave testing module. And anybody working with Arduinos knows that everything you take and do with Arduinos is in modules. Here's a picture of an assortment of 37 basic modules that everybody usually starts out with, and there are hundreds of others that you can take and buy to take and do specific things. But in reality, this is nothing new. If you take a look at this schematic of a Crosley radio from back in the 30s, you'll see that it's actually composed of a bunch of different modules. You have an RF amp module, a mixer module, IF amp module, first audio module, audio output module, local oscillator module, plus your power supply module. A lot of the changes in the early radios were just improvements on one module or another. One of the major improvements is they took and started making better tubes and could put more inside of a tube, is the combination of the RF amp, the mixer, and the local oscillator into one tube, and that took and brought us down to where we had the 5-tube radios, the All-American 5s. Later, when we took and moved on to transistor radios and stuff like that, everything is still modules. You have your RF amp, your converter, your IF amp, audio frequency module, and then your output module. And here again, if you take and look in radios from early to late, you'll take and see that it's improvements in individual modules and not usually a major change in the whole thing that you'll take and run across. Now let's look at some of the things we can do once we take and start breaking down a circuit into its component modules. This is a picture of an AM transmitter kit that you can take and buy at eBay. It has a 2-transistor modulator module across the top, an oscillator module in the lower left corner, RF amp, and antenna matching. If you look at the oscillator module, you'll see it has just a single inductor, which is going to give it a very limited frequency range as far as adjustments concerned. Now this is a picture of another AM transmitter that you can take and buy in kit form, made of the same 4 modules, only the modulator in this case is an LM386 IC, and if you look at the oscillator, you'll see that it has several different inductors you can take and choose from, giving a much wider frequency range. Since it has the wider frequency range, the antenna matching circuit also has multiple inductors to take and extend that range, but it still uses the same RF amp for the power output. Now, since they're both transistor circuits and both made of modules, that means that you can take and pick and swap what you want if you're taking and building one on your own. This picture here shows the first simple oscillator circuit and antenna matching circuit, but instead of a 2-transistor modulator, this one here it has the LM386 modulator from the second circuit. You can take and switch it around any way you want, use bits of this one, bits of that one, and as long as they're compatible voltage-wise, you're fine. I try to picture all schematics in terms of modules to see if there's something I can use in projects as I'm experimenting around here. For instance, one time I was looking for an audio oscillator module. I wanted one that would give me like 400 hertz tone and 1000 hertz tone, adjustable and level, but fairly constant in frequency. and I tried different RC circuits and stuff like that and could never find something that totally satisfied me. And then one day I was taking and watching an episode of the Radio Shop, and he was working on a Sencor CB24 Citizens Band radio analyzer. And the problem with the analyzer was that the audio test circuit on that wasn't functioning properly. Now, when I'm watching somebody work on a radio or a piece of test equipment, if possible, I like to have a copy of the schematic in front of me too, so I can take and follow along and see what they're doing. And this particular one here, I happen to notice that the audio frequency generator portions of it was LM324, and then going through a couple transistors for an audio output circuit to take and boost the signal. And this was exactly what I was looking for. So I took and copied down the components that, just the components from the schematic that I was interested in, and took and came up with the following schematic that I took and made. As you can see, it's a simple circuit, 14 resistors, 6 capacitors, one IC, the LM324 is a quad op amp. And from this I put a switch on the output to switch back and forth between the 400 Hertz or the 1000 Hertz, and then added the transistor amplifier circuit after that. So what I'm saying is, as you're looking at circuits, take and try to break it down into their basic component modules again, and keep in mind what those modules do and see if it's something that you can take and use in projects that you're making. Thanks for stopping by.